to again look at how these sensory receptors work, how they pass their information, is that there should be stimulation. That stimulation here, we are saying it is a physical stimulus. Okay, the changes that happen. Is it change in temperature, a change in pressure? Is it what? That is what causes the impulse the sensory neuron to get stimulated such that it can generate the action potential. The process of converting that stimulus energy into action potentials is what we call transduction. The next thing, if you have the impulse now, you need to transmit it, and it goes through the different neurons that we have talked about. And then when it reaches the brain carries out the interpretation, integration, and also making sure that there is memory about that information that it has received. So still, the process is basically the same. Input, that is the information that the sensory nerves get, that information comes from where? It can come from the internal environment or from the external environment. And then it is picked by the sensory neurons, and then you have that information and converted into electrical impulses and taken to the brain for processing, getting that information organized, and also storing. Okay, and then now the brain says, do this. That means the appropriate response is now going to be implemented based on the information that it has received. Now, we are going to look at transduction. How does the transduction happen? The transduction depends on largely what we call ion channels that exist within these sensory receptors. Remember, I'm using the word sensory receptors, sensory cells, receptors. I'm using them interchangeably, so don't get confused. So we are saying that the sensory neurons have ion channels. These ion channels allow it to have a resting potential of negative 60 to negative 70 millivolts. So this means that the inside of these sensory receptors is always negative inside and positive outside when it is not conducting any impulse. And that is why we call it the resting potential. Okay, now what we need to know is what happens when an impulse comes. Okay, now when you have the inside being negative, the outside being positive, that is the resting membrane potential. We can actually call that the polarized state. The cell membranes of these receptors are actually polarized. Okay, so you have the inside negative, outside positive. Now, when the impulse arises, then you will have what you call depolarization. Now, that depolarization is when you have the inside turning positive and then the outside turning negative, and that causes depolarization, and that is where the impulse is now fired. Now, the question that comes in next: what causes these changes in terms of the inside turning to from negative to positive? What causes that? Like I said, it is because of the ion channels. Now, at a resting membrane potential, what you will have is that you have, at least we know that when we have depolarization, that's when the impulse will be fired if you have the threshold being exceeded. Now, At resting membrane potential, you have the membrane being more permeable to potassium ions, and therefore this allows more potassium to move out. And that movement of the potassium ions out creates a slight negative charge inside relative to what is outside. Okay, and that in a way, that movement of the potassium ions out creates a kind of equilibrium where the rate of potassium exit and entry is actually balanced. So you have some getting out, then some getting in. So you have that dynamic equilibrium being established. So we can basically say that the potassium ions are largely responsible for the resting membrane potential. Remember, we have the sodium potassium pump that uh, moves the 3 sodium ions out and then 2 potassium ions in, and this is what creates the ionic gradients that is very important for the resting potential. Yeah. So what happens when you want to have the receptors, the sensory receptors actually being very responsive? Of course, there are different physiological mechanisms that ensure that you have these receptors being very responsive. Being very responsive is about the fact that they actually can respond even when you have slight changes within for the stimuli. Okay, so one point is that the different receptors have different thresholds for the stimulus intensities. This is to say that, for example, you cannot say that pain receptors are as sensitive as the photoreceptors. Okay, the intensities are different. Remember, there are some things that actually have to be kept within a tight range. So that is, for example, things that have to be kept within a tight range without, let us say, for example, glucose levels in blood. If you have a wide fluctuation in glucose levels, then you're going to have problems to do with hypoglycemia, low blood glucose levels, or hyperglycemia, where you have high glucose levels in blood. Okay, so that means that it is very important to detect deviations away from the normal. So you have certain receptors that can detect the slightest change, the slightest deviation from normal, such that for example, basically the good example I think we can use the thermoreceptor and the thermoreceptor. The normal temperature range between maybe 36.5 to 37.5. Okay, if you are going to have 38 degrees, that is already fever. If you're going to have less than um, 35 point, let us say 8 or 5, that is you're basically tending to, that is hypothermia, low low temperatures. Okay, so that means that it is very important that the thermoreceptors can be able to say, to notice that there is a change here, so we need to basically act. And then the other thing is about convergence. These are all receptors. But these receptors are connected to one sensory what? A neuron. That means you stimulate this, stimulate this, stimulate that, stimulate that. It is very easy to reach the threshold value, and then the impulse can be fired. So this is what we call convergence, that you have different receptors converging into one sensory neuron. That means that stimulation of this, even if you have small stimulations, they can result into stimuli that is actually above the threshold. Okay, so that is convergence. The other point is about summation. Summation. With this is that if you have small stimulations that cannot otherwise generate the action potential, but if they are actually multiple, then that the stimulation is basically combined or sum up. That's why we call it summation, and then that can generate an action potential. So basically here, the emphasis is that if you stimulate at the same time at a close points, you will see that the interpretation of that stimuli is combined. Okay, so simultaneous input combined to trigger a response. Okay, that also increases the responsiveness or the effectiveness of these receptors. And then the other point is what we call spontaneous activity. That some of these receptors are actually working, they are firing electrical impulses even without stimulation. That means that by the time you have stimulation, it is going to be very easy to generate the electrical impulse or the action potential. And then we are also having the fact, what we call sensory thresholds. That means that the firing basically should not go uncontrolled. Okay, the sensory receptors are also under the control of the central nervous system. That means that the central nervous system can make some of these receptors to be highly sensitive or can make them not to be very sensitive. So that marks the end of this presentation where we have looked at receptors. Receptors are found in every organ of the body. Okay, you can't talk about any organ that does not have any receptor, because these organs, these tissues, these glands all work through receptors, and therefore we have different receptors found in different parts of the body. They help us in making sure that physiological parameters are brought to the normal range. Okay, so they can sense pain, they can sense high blood pressure, they can sense the rate of heartbeat, they can sense the rate of breathing, they can sense issues to do with temperature, issues to do with iron. All these parameters that we can think about act through receptors. Even the drugs that we take, even the hormones, all these act through receptors. So that means that receptors play an important part in the working of an organism or in the physiological function of an organism. Thank you.